Good morning, friend. Now we have to talk about the wave particle duality. As we have seen, optical phenomena such as the diffraction and the interference that are result of the interaction of the light with the matter. These phenomena of light are completely explained with the wave theory by considering the wave nature of the radiation. But a phenomena such as the photoelectric effect, Compton effect, which occurs due to the interaction of the radiation with the matter, and this cannot be explained with the wave theory. This phenomena can be explained by considering the particular or corpuscular nature of the radiation. Okay, and Louis D. Broglie in 1924 the first predicted that the radiation can act like the wave sometimes and like the particle at other times. Therefore, like electron having particle properties exhibit wave properties under the appropriate condition. Nature loves symmetry, and it is true in case of the matter. Two fundamental forms, matter and energy, in which nature manifests herself. Energy radiation has been shown to possess a dual nature, and therefore matter must also inherit the same dual nature. De Broglie hypothesis for the matter waves. In case of the electromagnetic waves, it is known that the photons are associated with the waves. The energy of photon E is equal to h nu is equal to sc nu 0, where h is Planck constant, nu is the frequency, lambda is the wavelength, c is the speed of or so you can call the phase velocity of the wave, that is lambda into v. By using the mass energy equivalence as given by the Einstein equation, that we can take mass of photon m is equal to E by c square is equal to h nu by c square. Equivalent momentum P is equal to E by c h nu by c, which is equal to h lambda, and the wavelength lambda is equal to h by p, where p is the linear momentum of the photon. Then by analogy with this, de Broglie explained the moving particle is associated with a wave. It is called as a Broglie wave or say matter wave. The frequency of wave is taken as nu is equal to total energy by h, which is equal to mc square by h, and the wavelength is taken at h lambda is equal to h upon p, where p is the linear momentum of the particle. Okay, the velocity of the particle. This wavelength is called as the de Broglie wavelength. Lambda is equal to h upon p is called as the de Broglie wavelength. Properties of the de Broglie wavelength. Phase velocity of the phase velocity of the de Broglie wave is always greater than the velocity of electromagnetic waves in the vacuum. De Broglie waves produce dispersion even in the vacuum. Then the group velocity of the de Broglie wave is equal to velocity of the particle. Proof of the Bohr's first hypothesis using de Broglie hypothesis. There are the two experiments for the verification of the de Broglie wavelength, that are the Davison and the German experiment that you have to remember, and then the Thomson experiment. Now we have to talk about the important concept, which is as the Heisenberg uncertainty principle. Heisenberg principle is stated as in the simultaneous measurement of the position of the particle and its linear momentum both in the same direction, the product of the fundamental errors in the two will be the order of Planck's constant, that is a delta p into delta x is equal to h, where delta p is the error in the measurement of the linear momentum of the particle, delta x is the error in the measurement of the position, both the measured in the same direction. This principle can be stated in terms of the any other pairs of quantities, the product of which has the dimension of the Planck's constant h, that is the dimension of energy into time. Thus, delta E into delta T is equal to h, where delta E and delta are the error in the simultaneous measurement of the energy and the time. On this way, principle can be applied will be dl into delta theta is equal to h, that is angular momentum into the, that is a angular displacement will be equal to Planck's constant, that you have to remember. Proof of Heisenberg principle, we are not going in detail of such. Simultaneous, that you have to just remember, simultaneous measurement is position is impossible in general, but it is related with the Planck's constant, that you have to remember under this law. Application of the uncertainty principle, it is used to understand the energy determination, that as uncertainty must occupy at least a time interval h upon 2 delta E, or what is the same thing is that system maintains. Then the non-existence of the electron in the nucleus, Here are the numericals solved on this Heisenberg uncertainty principle and the de Broglie wavelength, but we are not again going in detail of this particular thing. We will directly move towards the questions. A black body is that body that dot incident on it absorb all radiation incident on the wavelength lambda is at which the black body emits the maximum amount of radiation is proportional to. Yes, T. In the body spectrum, as the temperature of body is increased, the peak wavelength shift towards the dot value, smaller value. For a perfectly black body, coefficient of absorption is 1. Wavelength of matter is lambda is equal to p by h. In the simultaneous measurement of the position, which is equal to the Planck's constant, or say vice versa, MCQs will be there that you have to remember. Okay, here we will stop. Thank you.